Okay, so we're given y equals 2x squared plus 6x minus 9, and we're told to graph it. Okay, so the first thing I want to do, I want to identify, does the parabola open up or down? Okay, well, because my leading coefficient is a positive number, then I know that it opens up. So the parabola is going to be upward facing. Now the next thing I want to find is my axis of symmetry. So when it's in standard form like this, we can find the axis of symmetry occurs at the vertical line, x equals negative b over 2 times a. So in this case, that would be negative 6 over 4, which is negative 3 over 2. So that is where my axis of symmetry occurs at. Next, I need to find the vertex. So this is the actual minimum point. So it always occurs on the axis of symmetry. So I know my x value is negative 3 over 2. And I'm going to plug this value in for x to see what y value I get. So this would be 9/4, 9/2. This would give minus 9. So 9/2 minus 9 is negative 9/2, and then subtract 18/2, so I think I should get negative 27 over 2, or negative 13.5. Somebody double checking? Yeah. Did you get something different?
Yeah, I don't think I did it right. So we plug in the negative 3 over 2 for x.
Yeah. Okay. 9/4 times 2 would be 9/2. Okay, now I know it opens upward. I know my axis of symmetry. I know the vertex. So I also need to find the x-intercepts, so where it crosses the x-axis, and the y-intercept. So I'm going to go ahead and find the y-intercept because it's easier. The y-intercept is found by plugging in 0 for x. So I plug in 0 here, that's gone. 0 here, that's gone. So I know my y-intercept is at negative 9. Okay, to find my x-intercepts, we plug in 0 for y. So that tells me 0 equals 2x squared plus 6x minus 9. And so again, you could use the quadratic formula to find the two x-intercepts, or the two possible x-intercepts. I would try to factor, so I would do a times c. 2 times 9 is 18. What multiplies to be 18, added or subtracted, is 6. Well, 1 and 18 wouldn't work. 6 and 3 wouldn't work. 2 and 9 wouldn't work. Well, that's nice. So I cannot factor. So the only way to find the intercepts is by using the quadratic formula. So I'm going to plug those in. So that's going to give x equals negative b plus or minus the square root of b squared minus 4 times a, which is 8. 8 times negative 9 is 72, all over 2a. So that would give negative 6 plus or minus the square root of 108, all over 4. So I know 108, let's see if I break that down, it'd be the square root of, so 16, 32, 64. 64 and 16 is 80. 80 and 16 is 96. 96 and 16, that ain't going to get me there. Okay, so 16 doesn't work. 25, 36, 36, 72. Yeah, so that's going to be 36 times 3 over 4. So that's negative 6 plus or minus 6 radical 3 over 4, which is negative 3 plus or minus 3 radical 3 over 2.
Okay, I got negative 12. So that's all. I got everything right, but I got the negative 12 instead of negative 10. But I just put that in my calculator.
This is negative 12
I got negative 12.
out here,
Yeah, you're probably right. I just put mine in my calculator. I just don't know everything.
and everything else looks just like this. Okay, so if it asks me exactly what my x-intercepts are, I'm going to put these in. Right, negative 3 plus 3 radical 3 over 2, and negative 3 minus 3 radical 3 all over 2. But if I'm having to graph it, like by hand, and get a rough estimation, I have no idea where that point is. Okay, so I would want to get a number estimation. So on your calculators, you could click the S to D button. Right, so my x-intercepts are happening approximately at, so negative 3 plus 3 radical 3. I really wish I had my calculator here with me. 3 plus 3 radical 3. I got 1.1 for the first one. And then if I did both of them as negative, so I've got negative 3 minus 3 radical 3 divided by 2. That one I got negative 4.1. So again, those are rough estimations. They're just going to help me when I graph this. Okay, so now I'm going to take all this information to get a general form of the graph. So I know it opens upward. I know the axis of symmetry is at negative 3/2, so I'm going to draw, each one of these represents 1. So let's say this is 1 and 2. So negative 3/2 would be right here, right between 1. That was terrible. Right between 1, negative 1 and negative 2. That's better. Now know that the y value for the vertex needs to be happening at negative 27 over 2, which is negative 13.5. So on my y-axis, I'm going to go by 3s. So I'm going to call this negative 3, negative 6, negative 9. Okay, then negative 27.5 or negative 13.2. I'm sorry, negative 13.5 would be right between negative 12 and negative 15. So I'm going to say that the vertex is right there. Now I also know the y-intercept is at negative 9, so it's going to cross the y-axis right there. My x-intercepts are at 1.1, which is right there, and negative 4.1, which would be right here. And so once I take all those critical points, I can kind of see the parabola taking shape.
What did you say that one at the very bottom, that dot right there you just crossed?
The vertex,
What was it?
jump it right here. You see it?
Was it big?
Negative 27 over 2, which I made into a decimal, negative 13.5. And so like when I grade these, I'm going to be looking for this information, and then is the graph somewhat like that? Okay, if you take this on computer, then you get graphing tools that help you make it exact because you tell it where to go. But so I'm not going to be super picky on the graphs because I'm not very good at drawing graphs myself. But I'm going to look at your information and I'm going to see, does this generally fit that criteria? So like even as ugly as my graph is, I would give that full credit because I can see all those points. They're hitting at the right, close to the right marks, and I clearly have identified all the points, what they are over here.
Okay, I need you to completely go over these.
Okay, so you could probably graph this one just the way it is currently, but when I used to work these problems, we didn't ever normally see them in this form. So for me, I'm going to put this in the general form of a quadratic just because it's the one I'm more comfortable working with. And we gave all those notes right at the beginning of how you could do it if you wanted to keep it in this form. But for me, it's just not beneficial enough that I would rather do it in the form I'm familiar with. So I'm going to distribute this out and get it into standard form. So this would be x plus 4 times x plus 4 minus 8. Then I would distribute here inside the parentheses first. So that's going to give x squared plus 4x is 8x plus 16 minus 8. Then I distribute the negative 2. That's going to be negative 2x squared minus 16x minus 32 minus 8. And then again, this is negative 2x squared minus 16x minus 40. So that would be the general standard equation for this parabola. Okay, so when I look at this, the first thing I want to identify does my graph open up or down? My leading coefficient is negative 2, just like it was here originally, negative 2. So I know that this graph is going to open down. So it's going to look like this. Okay, the next thing I would want to identify is my axis of symmetry. The axis of symmetry occurs at x equals negative b. So that'd be 16 over 2 times a. So that's going to be x equals 16 over negative 4, which tells me it's at x equals negative 4. Which again, we could tell that from the original because this was a plus 4. That means it shifted to the left 4. So same idea here. Now I want to find the vertex. So we find the vertex by plugging in negative 4 for x and finding the y value. So that would be 16 times negative 2. (16) times negative 2 is negative 32. Negative 32 plus 64 minus 40. So that's going to be plus 24. Negative 16 plus 24 is negative 8. Which, like I said, the more I look back at this, I may be better off just keeping it in this form. I'm just not comfortable working in it. But all those things that we talked about earlier still hold true. So we shifted left 4, and then we shifted the graph down 8. So that's where the vertex is occurring, right? Is it negative 8? So it would probably be a lot easier if you'll learn to work in that form. Again, just something I've not done a lot of. Next, we want to identify the y-intercept. So the y-intercept happens when the x value is 0. So I plug in 0 here and here. That leaves me with negative 40. So that's probably going to be hard to graph. But my y-intercept should be occurring at negative 40. And then to find my x-intercepts. So my x-intercepts happen when y is 0. So again, that would be 0 equals negative 2x squared minus 16x minus 40. And then I would try to factor negative 2 times negative 40 is 80. So what multiplies to be 80, added or subtracted is 16. 8 and 10 doesn't work. Say again. 20 and 4, absolutely. And they need to be different signs. So the 20 needs to be negative. So I would rewrite that as negative 20x plus 4x. So negative 2x squared minus 20x plus 4x minus 40. And now factor by grouping. So I group the first two together. They have a GCF of negative 2x. That leaves me with x plus 10. It's not going to work.
You don't have any x intercept.
Okay?
Because the vertex is lower than the x and it opens down.
Correct. So if we think back to what we had before, the vertex is at negative 4, negative 8, so somewhere here, and the graph opens down, so it would make sense that I would not have any x-intercepts. And again, that's backed up because when I factored, I got two different parentheses, right? This would be x plus 10. If I went forward, that would be a positive 4. That would give me x minus 10. So because my parentheses did not match, that means factoring did not work, which it should not work because there are no x-intercepts.
My calculator just kept saying math there.
Were you doing the quadratic formula?
Yeah, I just plugged it in and it said math there.
Right, so
I
just,
thought I was on a roll. I was like factoring, I was like, ooh, Tommy, I understand it. And then I pulled it, no, never mind, this ain't gonna work.
it did work. It told us there weren't any. Okay, so I know there are no x-intercepts. I know the y-intercept, so let's try to graph this. So again, my axis of symmetry is at negative 4.
So you knew there were none of the x-intercepts because the parentheses were different, right?
Yes.
Okay.
Now then, the vertex occurs at negative 4, negative 8. So I'm going to let my y's go by, I could do, I'm going to go by negative 4s. Negative 20, negative 24, negative 28. So again, when I plot this, I go to negative 4, negative 8, which is right here. And now the only thing that I need to make sure my y-intercept is at negative 40, that means my y-intercept is going to happen somewhere way down here, right? Because it does not fit on the graph. So make sure that you can't see your y-intercept right here if you've got it labeled like that. I do. And then just make it match up on the other side. Now, you could put your y-intercept on the graph if you changed what your y increments were. It's like you could make each y value represent negative 8, right? And then you could go negative 8, negative 16, 24, 32, 40. And then you could show where it crosses the y-axis. Okay, so on this page we have two equations that are in standard form, and we're told to write them in vertex form. So if we'll remember, vertex form is f of x equals a times x minus h squared plus k. So basically what's happened is my x to the second needs to be factored. Okay, now this is like the distributed out form, so I need to factor it to make it look like this form. So in this first case, I just have two terms. I have an x squared plus a 6x. So to factor that, I could just take a GCF. Well, that's not going to work. I take that back. Because if I did a GCF, that would give me x times x plus 6. And you see, I don't need the x on the outside of the parentheses. I need the inside x, and then I need that to be squared. So factoring on its own is not going to work. So we have to go back to doing something that you did when you first learned about factoring, which is completing the square. Okay, so here's the way we complete the square. We want to first Let's see if they do it on both these. No, they don't. So to complete the square, we want the leading coefficient to be 1. Okay, so in this case, it already is a 1, so I'm good. There's nothing I need to do. So what we do is we take the b term here, which is 6. We half that number. Half of 6 is 3, and then we square that number. That gives us 9. So I could rewrite this as f of x equals x squared plus 6x plus 9. Now, I can't just arbitrarily add 9 without balancing it out. So if I add 9 somewhere to keep it balanced, I need to subtract 9. If you'll think back to what we do now with equations, so like if you go back to when you used to solve this, x minus 2 equals 8, you were taught that you needed to add 2 to both sides. That kept it balanced. Okay, well now imagine you're not adding 2 to the other side, you're just subtracting 2 over here again, which is keeping it balanced in the same way. Again, you could think about it as if I added 2 here. Let me write it like this. If I added 2 here, I could move that positive 2 over and it would become negative. Right? It kind of seems useless back in the old context of solving an equation because you're just getting back exactly what you started with. Well, that's what we want to happen here. We want to get back exactly what we started with. So by adding 9 on the inside and subtracting 9 on the outside, it's still this same equation. So anyways, I now have it written. Now the thing that is in parentheses is a perfect square trinomial. That factors to be x plus 3 times x plus 3. And again, you don't have to write this step if you know where you're going, but I'm going to do it just in case we need to see it. But then this is the final step. X plus 3 times x plus 3 is x plus 3 squared minus 9. So now I took what was in general form and I have rewritten it into vertex form. So now, again, looking back at the last problem, it's pretty easy to see. We shifted the graph left 3 and down 9. So the vertex would be at -3, -9. And that's, again, why it's called vertex form, because it's very easy to identify the vertex when it's in that form. Okay, now same idea, except now I have a leading coefficient that is 2. So that's going to make the math a little more difficult. Okay, so let's say I've got f of x equals 2x squared minus 20x. Okay, and this plus 3 is really not benefiting me right now, so I'm going to move it farther down the line. All right, and I'm going to deal specifically with the 2x squared minus 20x. So if I look at just 2x squared minus 20x, I can see they have a GCF of 2. So I could rewrite this as 2 times x squared minus 10x. And then again, I'm going to leave this blank space because I know I'm going to complete the square. And then that plus 3 is still on the outside. Okay, so now this is the beginning of a trinomial, but I need to get a perfect number here so it becomes a perfect square trinomial. So now my leading coefficient is a 1. So we take our b term, which is -10. We half that number, which is -5. We then square that number, which is 25. So to make this a perfect square trinomial, we need to add 25 inside the parenthesis. Now here's where it's a little tricky. So did I really just add 25? No, I didn't. Because there's this 2 being multiplied on the outside. So what I'm really adding is 50. Do we see that? So to keep it balanced on the outside, I'm going to need to subtract 50. Now again, the perfect square trinomial is going to work out. This would factor to be, and again, if you see it, you can start skipping this step, but that is x minus 5 times x minus 5, and then plus 3 minus 50 gives negative 47. And so then again, we rewrite this. X minus 5 times x minus 5 is x minus 5 squared minus 47. And so the the vertex form, or as they typed in this sheet of paper, the vertex from, the vertex form is 2 times x minus 5 squared minus 47. Which means, again, the graph is shifted to the right 5. We shifted down by 47, and then we stretched it vertically by 2. So it's going to be a taller, skinnier graph than the original. Okay, so we're going to still continue to use our graphs, but now we're going to graph quadratics, which are parabolas, to solve inequalities. So again, an inequality is a set of numbers that satisfy the given condition. So if you'll think back to our standard inequalities, if I said x was greater than 10, that means the answers are everything bigger than 10. It could be 11, 12, 13, 15, but then there's some things that are not correct. So those would be things that like 8 and 4 and negative 6. So that is true for a linear inequality because we have just an x to the first power. It is linear. Now we have an inequality that has an x to the second power in it. So it's going to be a quadratic. So the way that we solve quadratics is we want to get everything to one side so it looks like it's in the form ax squared plus bx plus c. Now I always like for my leading coefficient to be positive, so I'm going to move everything to the left. So that would give me 2x squared plus 6x minus 56. And now then that's going to say, where is it less than 0? Okay, so if I wanted to go through all the steps of graphing this inequality, we could. I can see that it opens up. I could find the axis of symmetry. I could find the vertex. Okay, and if the homework problem makes you graph it to be correct, then you're going to need to do those things. But we don't have to graph the whole inequality to be able to solve, back that up. We do not have to graph the whole quadratic, the parabola, in order to find the answer to the inequality. What this is saying is, where is the parabola less than 0? So we think about that graphically. What does it mean to be less than 0? It means that the graph is below the x-axis, because right here is when my y values are less than 0. So what this essentially wants to know is, where is the parabola below the x-axis? Well, it's going to happen, again, because I know it opens up, I know it's going to happen between the x-intercepts, right? Now, it could happen that I have no x-intercepts, and then when I try to find those, then I will get nowhere. So that would be there's no solution. It does. It could happen that it just touches at one point and I get one x-intercept, but that's still never below 0. So that would be no solution. So what I'm looking for, if I can find 2 x-intercepts, say here and here, then I know, because the graph opens up, that it's going to be less than 0 between those 2 x-intercepts. So what I want to do is find the x-intercepts. So when I look here, 2x squared plus 6x minus 56, you could use the quadratic formula. You could try to factor. Again, I normally like to factor. So it multiplies to be 112. So what multiplies to be 112 added or subtracted is 6. That's a great question. 13, 14. Let's see, what's 112 divided by 14? 8 and 14, that is perfect. So I'm going to rewrite this as 2x squared plus 14x minus 8x minus 56. And then again, we GCF. So that's 2x times x plus 7. This would be negative 8, x plus 7. So that factors to be 2x minus 8 times x plus 7 equals 0. So that would be at 2x equals 8, x equals 4, and x equals negative 7. So now I know, again, general form of the graph, I know it opens up because the leading coefficient was positive. I know it has x-intercepts at positive 4, which is here, and at negative 7, which is here. So again, and I just have a general idea of what it does between those, right? I don't know exactly. But because I know where it changes from being a negative number to a positive number, I can solve the inequality, which is where's the parabola less than 0? Well, it's less than 0 between negative 7 up until 4. So again, think about our interval notation from negative 7 to positive 4. Those are not included because we're only looking for where it's less than 0, not less than or equal to 0. If it would have been less than or equal to, we would have put the brackets. But because it is not equal to, we put parentheses. Okay, so same idea here. X squared plus 6x is greater than or equal to negative 8. I want to get everything to one side so it looks like a quadratic. And I like my leading coefficient to be positive. So I'm going to keep that on the left, move the negative 8 over so it becomes positive. So now I'm looking for where x squared plus 6x plus 8 is greater than or equal to 0. So this time, where is the parabola greater than or equal to 0? So I'm looking for where it is above the x-axis, up here. So again, can that factor? Yes, it can. So that's going to be x plus 4 times x plus 2 is greater than or equal to 0. So my x-intercepts occur at negative 4 and at negative 2. So I got negative 1, negative 2, negative 3, negative 4. So right here is an x-intercept. Right here is an x-intercept. And now, which way does the graph open? Is it up or down? Well, my leading coefficient is positive, so I know that my graph is going to be opening upwards. So I know the graph looks something like this. No. That's just, I'm just not a very good drawer. No. Now, y'all like that one better? It doesn't matter because all I'm interested in here is the solution to the inequality. If so, now I know which way the graph is opening upward, and I know where the x-intercepts are at negative 4 and negative 2. I need to tell now where is the graph above or equal to 0. Okay, well, when I first approach the graph, it is greater than or equal to 0. So all the way back at negative infinity, this graph is greater than or equal to 0. And it stops being greater than or equal to 0 at negative 4, but negative 4 is included because we're looking for where it's also equal to 0. So when I get to that point, the graph changes from being above the x-axis to below it. And it stays below it all the way until I get to the number 2. And so there's another portion of the graph that is above the x-axis, so I need to put a union. It starts becoming positive again at -2. And again, that's included because I'm looking for it's also equal to 0. And it stays above the x-axis the rest of the graph, so all the way to positive infinity. Physics is the application of math in science. So math is its own science. And physics is using real-world problems and using math to solve it. Math explains all parts of physics. Well, that's why I taught physics for 3 years or 2 years, whatever it was. Does it make me want to what? Sell what? Oh, no. I enjoy physics. Okay, so if a football is kicked straight up with an initial velocity of 128 feet per second from a height of 5 feet, then its height above the ground is a function of time given by h of t equals -16t squared plus 128t plus 5. What is the maximum height reached by this ball? So when you really work physics, they don't normally give you that formula. You have to discover the formula for yourself, but they're being very nice to us here in this example. So we know the height of the football is given by this equation, -16t squared plus 128t plus 5. And so again, this is going to tell me the height of the football. So again, what am I being asked to find? I'm being asked to find the maximum height. So when I look at this equation, it's ax squared plus bx plus c. I know it's a parabola. And I also know, because this leading coefficient is negative, that it's going to be a downward facing parabola. So when does the football reach its maximum height? At the vertex, before it starts its descent back down. So I need to find the coordinates of the vertex, and whatever the y value is will be the actual height of the football. So in order to find the y value, I must first find where it occurs. So I need to find the x value to plug in. We can find the x value because we know it's on the axis of symmetry by using -b over 2a. So that is -128 divided by -32. So that should give us 4. So that means after 4 seconds, and again, I should be using t's instead of x's. It's the same difference. T's for time. After 4 seconds, the football reaches its maximum height. So I'm going to plug in 4t, to find out what that height was. So that would be at -16 times 4 squared plus 128 times 4 plus 5. So this would be 16 times 16 is -256. This would be 256 times 2, or times 2, that would be 512 plus 5. I don't know why I put a parenthesis there. So this would be 256 plus 5, which is 261. So the football's maximum height was 261 feet. Are we in feet? Yes. 261 feet above the ground.